Hey, Dr. Ray here, founder of the Learning Liaisons, and welcome. Welcome to our Wednesday evening math sessions featuring our math specialist and your math specialist, Amy Sink. In the next hour, Amy has put together a sample set of approximately 10 practice questions that run the gamut from kindergarten levels all the way through 12th grade high school math. Now, I know you are attending here, watching this, and you're like, well, I'm doing elementary in Texas, or I'm doing elementary in Praxis, or I'm doing high school math in Florida, or middle school math in Texas. And what's going on here, right? So we're doing these sessions to help you guys out and provide you with different ways to look at problems and to build that confidence. Because here at the Learning Liaisons, one of our major objectives is to clear up the testing confusion, give you the support you deserve in order to nail your exam and be done with it. So our focus is on math. Now, are we going to be just focusing on high school math the whole hour or elementary? No. We've got a mixture here. Now, Amy's going to go through a bunch of problems. You're going to have the opportunity to download those as a PDF. So when Amy starts, just pay attention to the screen. We're going to have a message there for you so you can download the PDF in case we don't get to all the problems or want to practice on your own. She's going to do her best to go across all different grade levels. If you have a question, you feel free to ask Amy your question as well. We're teachers here too, so we can multitask. Our job is to make sure that we give you what you need to be successful. But if you're like, dang it, I didn't have any questions this week, don't worry. We'll be here next Wednesday night as well. So bring those questions with you if you want, and you could ask Amy away. Because here at the Learning Liaisons, we pride ourselves in providing you guys the support you need to pass your exam. So whether you're our Florida teachers here with our FTCE exams, our national exam Praxis peeps, big shout out to you guys out there too, and especially our newcomers to the Learning Liaisons brand, TExES Prep. So whether you're elementary, middle school, and high school, we've got your back. So sit back, relax, grab your popcorn, get ready to learn some math, and stay tuned for the end because I'm going to jump back on to close this out. And I got a special surprise for you guys who really want to get the real deal prep and get everything you need to be successful and practice, clear up that confusion, and pass your certification exam on the next attempt. So, welcome to the Learning Liaisons community. Always remember, it's when you pass, not if you pass. So without further ado, let's turn it over to the reason why you're here, Amy. You with us, Amy? Let's get going.
Hey everybody, welcome to Wednesday night math night. As Dr. A said, my name is Amy Sink and I am one of the math specialists here at the Learning Liaisons. And we are here every Wednesday just to help you feel more comfortable in math, to help you gain more math confidence and more math knowledge. So we go over, I'd say, 7 to 10 problems every week, like Dr. A said, ranging from kindergarten through 12th grade. And I always like to cater the problems to something that you want to see. So as we're working together, if there is something, a topic or a question that you're like, I really wish she would go over this, let me know in the comment box because I will absolutely use that to guide the question building for the upcoming weeks. Because yes, I love doing this. I love being here with you guys. However, this is really for you. And so I want to be able to cater this 1 hour free session of tutoring really for you to be able to benefit from it. All of the questions that I build and choose for these kinds of sessions, I try to make relevant for everybody in one way or another. And so even though we might be doing a calculus problem, I will attempt to make it relevant for everybody and vice versa in some way, shape, or form. Before we get started, I always like to do a get to know you question. It makes it seem less like we're sitting here in front of a computer and more like we are just chatting in my living room doing math. So let me know in the comment box, where are you from? What test are you prepping for? And the get to know you question, let's do this. What is the best concert or show you have ever been to? And I'm only doing that because my shirt is ABCD, but like it's like rock band, kind of like AC/DC. Get it? So what's the best concert you've ever been to? This is going to sound so cheesy, but my favorite concert I've ever been to is the Backstreet Boys. But like 3 years ago or 4 years ago, when they were back on tour, I went with some of my best friends and it was the best time ever. So that is my favorite concert. What is your favorite concert? And where are you from and what test are you prepping for? I am from Central Florida. We do not go to Disney every single weekend, even though it's right. I feel like it's right in our backyard. And yeah, that's a little bit about me. So without further ado, let's go ahead and get started with our first problem. Now, this problem is geared, it's a calculus problem. Like this is for my high school people. However, I will try to make it relevant for everybody. So let's read the problem together. Find the slope of the line tangent to the point 1, 9 that lies on the graph y equals 2x squared plus 8x minus 1. All right, so when my high school people see slope of the line tangent, you should immediately think of derivative. You should immediately think of derivative because when we take the derivative of an equation, it gives you the slope of the line tangent at whatever point you plug in. So when we think about what this graph looks like, this graph is an upward facing parabola. Is it there or is it here? I don't know, but it doesn't really matter for this purpose, right? Like I could figure out exactly where it is by finding the vertex and finding all that, but we don't need to. We just need to know it's an upward facing parabola. And by taking the derivative, I can find the slope of all of these little tangent lines that are intersecting this graph right here. So when I find those tangent lines, I can find the slope of them by finding the derivative. So when I find the derivative, I'm going to use in this situation the power rule. So drop the exponent, multiply it by the coefficient, 4x plus 8. And if you don't understand how to find derivative, then honestly, if you don't understand how to find the derivative and you're taking a 7th through 12th test, I wouldn't super stress about it because calculus usually isn't a huge part. But if you want to know the basics of how to find a derivative, I would learn the power rule and move on. So this is the derivative of the function, y equals 4x plus 8. Now, when I plug in an x value, it will spit out the slope of the line tangent at that graph. So if I say, let's move this over a little bit. If I take this and move it so that we can better see this, if I plug in x is 1, 2, 3, 4. If I plug in x is 4 into this equation, I am going to find the slope of the line tangent at 4. If I plug in -2, I'm going to find the slope of the line that hits my parabola at -2. This looks like the equation of a line, but it's not just the equation of a line. It is spitting out, the input is the x point, but the output is the slope of the line tangent. Now, if you're just joining us, listen, and you're taking K through 3, GK, Praxis core, and you're like, whoa, calculus, I'm out. Don't leave yet. I promise. This is problem 1. We will get to some stuff that you need. So don't run away yet. So I am trying to find the slope of the line tangent at the point 1, 9. So I'm going to plug in my x value of 1. So the derivative at 4 times 1 plus 8, 4 plus 8 equals 12. So the slope of the line tangent to this point is 12. Now, I want to take this problem one step further. The next problem says, find the equation of the tangent line that intersects the graph at 1, 9. So in this problem, we were finding the slope of the line tangent. In this line, we're finding the actual equation of that tangent line. So if we redraw our graph and we're looking at the point up, 1, 9. So we have to pretend that like this graph goes like this. Okay, it doesn't, but we're just going to pretend. So find the equation of the tangent line that intersects this graph at 1, 9. So if this graph goes through at 1, 9, right? And this is not what this graph looks like at all because it has a y-intercept of -1, but we're just not even going to go there. So if this graph, and we're trying to find the equation of the line at 1, or the equation of the tangent line, I'm trying to find the equation of this line at over 1, 9, right? So I already know that the slope is 12 because we solved for that in the previous problem. What do I need when I'm trying to write the equation of a line? Yo, this is for everybody but elementary. This piece, what do I need to write the equation of a line? To write the equation of a line, I need a slope and a point or a y-intercept. Do I have a slope? I do. 12. Do I have a point? I do. They gave it to me. So can I write the equation of a line? Point slope form. Y minus y1 equals m times x minus x1. Plug in my slope, plug in my point, and I have the equation of the tangent line. The funny thing is when people see this problem, they completely forget about all the pre-algebra, algebra 2 that they have. They forget about all that knowledge that they have. And they're like, the equation of the tangent line, I don't know how to do that. But you just found the slope of the tangent line, and they gave you a point. If you have a point and you have a slope, you can find the equation of a line. Let's plug that information in. So y minus y1 equals slope times x minus x1. And we solve. Now, I can't leave it like that because when I look at my answer choices, they are all in slope intercept form. So again, non-calculus people, you got to know the difference between point slope and slope intercept. These are all in slope intercept form. So I just need to convert my point slope form into slope intercept form. So I'm going to distribute. So y minus 9 equals 12x minus 12. Add 9 to both sides. Y equals 12x minus 3, which is B. Questions? All right, let's go ahead and move on to problem number 2. Remember, in the comment box, let me know what you want to see from me next week, and I will absolutely include it in my next week list. Let's go ahead and move on to problem number 2. A journalist in a town with a population of 15,200 takes a random sample of 200 people and finds that 60 of them read the local newspaper. Based on this sample, which of the following is the best estimate for the number of people in the town that read the local newspaper. So there are two different ways that we can solve this problem. There's two different ways we can approach this problem. So I'm just going to draw a line down the middle because we're going to solve it both ways, because some of you are going to approach this problem one way and some of you are going to be more naturally inclined to approach this problem another way. So a journalist in a town with a population of 15,200 takes a random sample of 200 people and finds that 60 of them read the local newspaper. This problem is really for everybody. This hits almost every single person's blueprint or study companion or standards in one way or another. So, if there are a sample of 200 people and 60 of them read the newspaper, I can say that 60 out of 200 people read the local newspaper. That's my sample. Now, if I convert that into a decimal, I can just plunk that into my calculator. 60 divided by 200. And that equals 0.3 or 30%. So now if I take 0.3 or 30% and I multiply it by my total, then it's going to give me 30% of my total population. So like it said, based on this sample, what is the best estimate for the number of people that read the local newspaper? So if 30% of the sample reads the local newspaper, we can safely assume, based on this problem, that 30% of the entire population is going to read the newspaper. So 30% times 15,200 equals 4,560. Now, the problem said, what is the best estimate? So we are estimating based on their estimating rules, not my estimating rules. So their estimating rules, it looks like my choices are 5, 45, 450, or 4,500. So in this situation, I am going to choose 4,500 because that is the closest to 4,560. Questions? Any questions about that problem? My computer randomly disconnected, but I'm going to reconnect and we will be good to go. Any questions about that problem of the sample set? All righty, let's go ahead and move into some geometry. Geometry is a very popular thing that people ask me to go over every week. So let's go ahead and do a little bit of geometry. I'm going to reconnect my iPad and we will be good to go. As we're sitting here, I want you to think, what do you struggle with? Do you struggle with statistics? Do you struggle with probability? Do you struggle with algebra? Do you struggle with geometry? Is there a specific subsection within that you struggle with? So like some people are like, I know my shapes, but when it comes to remembering formulas, I am not good at that. So is there something specific that you're struggling with, or even a problem, like a specific problem that you're like, man, I really like, there's this problem that I really need help with, and it would really help if you could go over this. That is what we are here for. So let me know while I'm trying to connect my iPad, and we will go from there. All right. Welcome to dance class. While we're waiting for the iPad, waiting for the iPad, waiting for the iPad, waiting for the iPad. Okay, it's not working, so we're going to do it like we did last week and connect via the PowerPoint. Oh, Lydia, you do not have access to a calculator. That is disappointing. Yes, Florida actually just shifted and they finally gave access to the K through 6 people to have a calculator. I will be very interested to see if and when EC6 or TExES gives access to that calculator. It took Florida a while, but Florida finally gave K through 6 access to that calculator. So it'll be interesting to see if Texas ever follows suit or not. So yes, I can show you how to solve that without the calculator. Absolutely. I am just trying to get something to connect so that we can move forward with our session tonight. Let's see. I will solve that problem without a calculator right now. Inverse matrices. So like finding the inverse matrix, Zelma, that's a really good one, actually. I love that. I will add that to my next week. All righty, next week. Inverse matrices. Okay, I have added that. Let's go ahead and solve that other problem. All right, let's go ahead and solve this the other way. So this same journalist is in town, and now we are going to solve with a different formula. So instead of doing the whole percentage thing, let's go ahead and solve it a different way. So we are going to do cross multiplication. So when we set up a proportion or a cross multiplication, we are going to make sure that we have the same thing comparing. So on the top, we're going to put the newspaper readers, and on the bottom, we're going to put our total. And that's going to equal newspaper readers over total. So my total population is 15,200. So I'm going to erase this, and I'm going to write 15,200. Do I know how many newspaper readers I have in that selection? No, that's what I'm trying to figure out. But what I do know is that in a population of 200 people, I know that 60 of them read the newspaper. So now what I can do is I can cross multiply to solve. So 200 times n is 200n equals 15,200 times 60. Now, this looks really funny because I'm using a trackpad to try to write. So that's why the handwriting is like not so good right now. Now, Lydia, you asked how to solve this without a calculator. In this case, we would have to do long multiplication. So 15,200 times 60. Placeholder 0 because I could go across 0, 0, 0, 0, 0, but it's useless. And then 6 times 0 is 0. 6 times 0 is 0. 6 times 2 is 12. Carry the 1. 6 times 5 is 30. 3 and 6 times 1 is 6 plus 3 is 3. So that equals 302,000. right? And I'm going to just check that in my calculator because I do have a calculator. So 15,200 times 60. Ooh. Oh, because 6 times 1 is 6 plus 3 is 9, not 3. Oopsies. That's why I checked it with my handy dandy calculator. So 15,200 times 69. Goodness gracious. I really royally messed that up. That was 31, not 30. So 912,000. So I have 200N equals 912,000. Now, from there, I can divide both sides by 200. And Lydia, from there, you could divide both by 200 and just see like what kind of estimate you got. But if I was to use estimation strategies here, which is absolutely a strategy that you can use, and it often is quick. If I was using estimation here, I could divide the 912 by 100, which would really just move my place value over by 2 because it's a base 10. And so that leaves me with 9,120. And then if I knew that I was dividing by 200, I already divided by 100. So then I could cut that 9,000 in half and it would be about 4,500, right? It's not going to be 450. It's not going to be 45 and it's not going to be 5 when I use that estimation strategy. I don't need an exact number. 4,500 is nowhere close to 450. So by estimating this quotient, I don't need a calculator. I hope that makes sense, Lydia. So that's just another way that we can solve this problem. Absolutely. Hey, April, it is good to see you. You got a 169. Any tips? I have all sorts of tips. If you are not in our boot camp, our GK boot camp is probably one of the most successful boot camps that we have. We have a super duper high pass rate. So if you are not in the boot camp, that is something that I would highly, highly, highly recommend. And then I would also suggest using your score report to see where you are. And this is good for anybody in this room. Like if you did not pass your exam, look at your score report and figure out like where those areas of weakness are. And then if you need one-on-one help, reach out to Priya or myself on our website and schedule a one-on-one tutoring session so that we can really focus on those areas of deficiency. But I would suggest that boot camp for sure because the GK boot camp is definitely the highest success rate we have, like 90-something%, which is huge. So, all right, let's go ahead and move on to problem number 3. Ooh, geometry. All right, here we go. Two similar cylinders have a scale factor of 1 to 3 for their corresponding dimensions. If the I was yawning. If the smaller cylinder has a volume of 100 cubic centimeters, what is the volume of the larger cylinder? If the smaller cylinder has a volume of 100 cubic centimeters, what is the volume of the larger cylinder? All right, so I worked this problem out with a tutoring client this weekend, and it tricks everybody. It really does. It tricked me the first time I solved it. So let's think about this. I have 2 similar cylinders. So I'm actually going to insert a shape just to make our life a little bit easier. So I have this cylinder, and then I have this cylinder. And they have a scale factor of 1 to 3 for their corresponding dimensions. So that means that like the height, if I'm looking at the height of my cylinder, it has a scale factor of 1 to 3. So what does that mean? If this height is 3, and we'll go with 4 so that we're not using 3. If this height is 4, then this height is going to be 12. Why? Because we have a ratio of 1 to 3. So I'm going to multiply the 4 times 3 to get 12. So with that said, my radius, let's take a look at my radius. Let's say my radius is 5. Then my radius here would be 15. So if this has a volume of 100, which y'all, that was just so crazy. Okay, so if you're a super math nerd like me, I just discovered that I created a cylinder that actually has a volume of 100 without even trying. So area equals, and we're going to do it in terms of pi just so that we don't have to worry about it, but area equals pi r squared. So like think about the volume of a cylinder. Volume of a cylinder is area of the base times the height. So it's pi r squared h. V equals pi r squared h. R is 5. So pi times 5 squared is 25 times 4. What's 25 times 4? 100. So the volume equals 100 pi. Oh my gosh, that's crazy. So if the volume of the smaller one is 100 pi and it has a scale factor of 1 to 3, most people are going to choose B as their answer, especially when they're in a rush. But this is why I love to create examples, even if I was solving this problem on my own. So if I didn't understand scale factor in real life, if I was taking this test, I would draw 2 cylinders and I would create heights and radiuses that equaled 100, and then I would create another cylinder with a 1 to 3 scale factor and then find the volume of that. And you're going to see why here in a minute. So volume equals pi r squared, so 15 squared times 12. 15 squared is 225. So volume equals pi times 225 times 12. 225 times 12 is 2,700 pi. Now, why in the world is this 200 or 2,700 pi when the scale factor is 1 to 3? Because scale factors reference linear measurements. So when I'm increasing my linear measurements by a scale factor of 3, think about what that's doing to the volume as a whole. If my height is increasing by 3, my width is increasing by 3, and my length is increasing by 3. If all of those things are increasing by 3, then my volume is going to increase by 3 times 3 times 3. My volume is cubic. So when I'm looking at scale factoring, I need to take into consideration what scale I'm using. So when they give you a scale factor, it is in reference to the linear measurements. If they said, what is the area of the circle, then I would take that 3 and I would square it and I would multiply this times 9. But because we are looking for volume, I can take that 3. I can cube it. It's going to give me 27. So the volume scale factor is 1 to 27. So I can take the 100, multiply it by 27, and get 2,700 without doing any of the work that I just did. Let's go ahead and explore what this could look like without doing all of that work. So let's erase all of this and let's pretend like these numbers are different, okay? So I'm going to erase all of this really quickly, and I want us to do one together and show you how easy this problem really could be. Okay, so two similar cylinders have two similar prisms have a scale factor of 1 to 4 for their corresponding dimensions. If the smaller prism has a volume of 125 cubic centimeters, what's the volume of the larger cylinder? Well, if the smaller prism has a volume of 125 and my linear scale factor is 1 to 4, then my volume scale factor is going to be 4 cubed. 4 times 4 times 4. Well, 4 cubed is 64. So I can multiply 64 times 125. And I really need to get rid of this too, because these are not going to be my answer choices. And then 64 times 125, the volume of the larger prism is going to be 8,000. That's how easy scale factoring is. There's not much to it if you truly understand the relationship of scale factoring, linear, area, and volume. Does that make sense? All right, let's go ahead and move on to the next problem. Lydia, it's really not nice that they don't give you access to a calculator. You are absolutely right. You are welcome anytime. That's why we're here. Ask questions away. All right, let's go ahead and move on to the next problem. Simplify, parentheses, 3 minus 9 times, parentheses, negative 2 plus 3, closed parentheses, divided by, parentheses, 3 minus 5. All right, so this is a classic just order of operations problem. Everybody needs to understand how to solve it. Everybody needs to understand how to do it. And regardless of whether you're taking GK, Praxis Core, elementary, or high school math, we all make similar mistakes. So let's go ahead and work through this problem together. What do we know about order operations? We know that we operate under PEMDAS. So please excuse my dear Aunt Sally. Parentheses, exponents, multiplication, division, addition, subtraction. I ran out of space there. Now, when we consider that multiplication and division are married and addition and subtraction are married, which means that when I finish with my parentheses and my exponents and I get to multiplication and division, I'm going to do multiplication and division from left to right. So if division shows up in my problem before multiplication, it does not matter. I'm going to still solve it from left to right. So I am going to go ahead and solve 3 minus 9 because that's in parentheses. I'm not going to do multiplication or division yet. Then I'm going to do negative 2 plus 3 and 3 minus 5. I'm going to do all three of those in the same step because all three of those are in parentheses. So 3 minus 9 is negative 6 times negative 2 plus 3 is 1 divided by 3 minus 5 is negative 2. Oh my goodness, I just realized I actually changed this problem like in my notebook and I changed the answer choices, but I didn't actually change the problem. So we're going to just erase these answer choices and we're going to just solve this problem like it's a fill in the blank. And we will do the problem with those answer choices next week because I never actually changed the actual problem. I know what the problem is in my head, but I never changed it. So let's just finish this problem out. Now that I have finished parentheses, now I am going to do my multiplication and division section. So I'm going to move from left to right. Negative 6 times 1 is negative 6 divided by negative 2. And we all know that a negative divided by a negative is a positive. So negative 6 divided by negative 2 is positive 3. Pretty simple, straightforward problem. Questions about it? All right, let's go ahead and move on to the next problem. Oh, this is a good one. I'm excited for this one. What change would need to happen to the slope to make the following lines perpendicular? What change would need to happen to the slope to make the following lines perpendicular? All righty. So, in order to figure out the change that would need to happen, I need to figure out, are these lines perpendicular? And if not, why not? So let's go ahead and explore that concept first before we figure out what change needs to happen. Can I figure that out in the state that these equations are in right now? Can I figure that out in the state that these are in right now? No, because in standard form, I cannot visually see my slope right away. So I need to manipulate these equations to put them into some other format. So I am going to take these equations and I am going to manipulate them so that and I just kind of copy and pasted it so that we could do it separately. So I'm going to go ahead and put these in slope-intercept form. Slope-intercept form being y equals mx plus b. So I'm going to try to get the y by itself. So I'm going to subtract x from both sides, and I'm left with negative 3y equals negative x plus 12. Now I'm going to divide by negative 3 because then that's going to leave my y by itself. So I'm left with y equals negative 1 divided by negative 3 is positive 1 over 3, x. And it's okay to have fractions. They're not scary. 12 divided by negative 3 is negative 4, minus 4. So there's my first equation. Let's move over to our second equation. I'm going to do the same process. Subtract x from both sides. 3y equals negative x plus 6. Divide everything by 3. Y equals negative 1/3 x plus 2. So, what would need to happen to the slope to make those lines perpendicular? Nothing. Those lines are already perpendicular. Excellent. How do I know that those lines are already perpendicular? Because perpendicular lines have negative reciprocal slopes. So that means that if the slope of one line is a over b, a and b being digits, then the slope of the perpendicular line is going to be negative b over a. Oh my gosh, these are not perpendicular. I am so sorry. These are not perpendicular lines. 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 So here's why. Because this is 1/3 and this is negative 1/3. They're not flipped from each other. I have a positive 1/3 and I have a negative 1/3. In order for these lines to be perpendicular, one would have to be 1/3 and one would have to be negative 3 because I have to flip it. I don't know why I thought those lines were perpendicular. So What do I need to do? Not nothing, because these lines are definitely not perpendicular. Multiply the slope of the first equation by -1. If I multiply -1 times 1/3, that's going to give me -1/3, which is going to match this equation, not make it perpendicular. That would make them parallel. So that's not the right answer. Multiply the slope of the first equation by -1. Not the right answer. Multiply the slope of the second equation by 9. That seems a little obnoxious, but let's test it out. -1/3 times 9. -1 times 9 is -9 divided by 3 equals -3. Well, would you look at that? That right there turned our first equation and second equation into perpendicular lines, because the first equation has a slope of 1/3 and the second equation has a slope of -3. So we have just made these lines perpendicular by multiplying that second equation, the slope, by 9. Now, that in turn does not mean I have the same lines, right? Because if I'm changing the slope and not anything else, then I'm not going to have the same line, but I didn't want to, because I wanted to create two perpendicular lines. Does that make sense? Zelma, you are absolutely correct. It should be a -3, not a -1/3. So thank you for catching that error. All right. Questions, concerns? I think we have time for one more problem, maybe two, depending on how quickly we move through these problems. Which of the following quadrilaterals does not have at least one pair of parallel sides? Which of the following quadrilaterals does not have at least one pair of parallel sides? Lindsay, are you asking about the perpendicular parallel lines question? Just let me know, Lindsay, which question you're talking about, because that comment came through as I was reading this problem. So I'm assuming you're talking about this problem right here. So, oops, I accidentally clicked the wrong button. You're talking about this problem, the PEMDAS problem? I just want to make sure I'm answering the right question. So let me know. Is it the PEMDAS problem? Is it the PRISM problem, like where it was like a scale factor of 1 to 3? Is it the population problem? Is it the line problem? Or is it the quadrilateral problem? Which problem is it? And I will absolutely answer that question. Which of the following quadrilaterals does not have at least one pair of parallel sides? April made a great point. She said, I've definitely seen something like that before. This problem, which of the following quadrilaterals does not? Which of the following quadrilateral does? Which of the following shapes has the following properties? Knowing your properties of shapes is critical for everybody. They love to say, here's a list of properties. Which of those properties matches a parallelogram? Which of the following shapes does not have right angles? Which of the following shapes does not have perpendicular diagonals? Knowing that vocabulary is critical. So which of the following quadrilaterals does not have one pair of parallel sides? A parallelogram is absolutely going to have one pair of parallel sides. In fact, it has to have two pairs of parallel sides by definition. So it's not A. B, a rectangle. Well, a rectangle is a parallelogram. It has to have two sets of parallel lines, but a rectangle also has other stipulations, 90-degree angles. So it's not a rectangle either. And in fact, it's not a trapezoid either, because a trapezoid has to have at least one set of parallel lines. And so this has one set of parallel lines. So it is not a trapezoid. The quadrilateral that does not have one pair of parallel sides is our kite. What a kite has is two adjacent congruent sides, but they are not parallel. So D is the correct answer. All right, Lindsay, you were asking about the graphing problem. Were you talking about this one way back here, the slope of the line tangent? So I'll just run through all of these. This one is absolutely written how it is a high school 6 through 12 calculus problem. This one right here, two similar cylinders have a scale factor. Scale factors is about like GK, Praxis core, middle school and high school. PEMDAS is everybody. Change to perpendicular lines, that would be GK, Praxis core, middle school and high school. And this one would be everybody as well. All right. We are going to wrap up for the evening. So in the comment box, let me know, what questions do you have in the upcoming weeks? What do you want to see me go over that I haven't gone over? Or maybe there's a problem that you're like, man, that one really stumped me. Can you go over another one like that? Let me know in the comment box, and I will be happy to add that to the upcoming weeks. I hope that you guys are having an amazing week. We are going to be back here again next week after Memorial Day. And I feel like Memorial Day is like the kickoff to summer. And I feel like that's like when everyone's like, it's summertime. So I feel like next week is going to be our kickoff to summer, even though we started summer hours last week. Don't forget, we are here at 5:30 throughout the summer. I am going to turn it back over to Dr. A, and I will see you guys next week. Have a fantastic rest of your week and your Memorial Day weekend, and I will see you next week.
All right, so wasn't that an amazing session? Now, I know, depending on what exam you have to take, you're like, man, that was great, but she didn't address everything I needed. She focused on all different questions, and I just need elementary, or I just need middle school, I just need high school. Don't worry. Since you're still with us, I've got a special surprise for you. If you use the coupon code, all capital letters, SINK35, that's SINK 35. That will take off 35% off any of our prep courses on our website at the Learning Liaisons. It doesn't have to just be math. It could be anything that you need that we offer. And this is going to be an ongoing deal for you guys who attend these live sessions, because these are great. I'm sure Amy opened your eyes to some new concepts, some new ways to tackle problems, building that confidence. But this is just a smidget of your exam, the concepts on your test. So if you want the comprehensive view with the practice with Amy, with the practice test, with the lessons and the content review, we've got your back on our video boot camps, which all of them feature Amy Sink, your math specialist. So if you want to take advantage of that, the code is SINK35. You can use that at checkout on the learningliaisons.com website. And all that information is on our website as well, and on the bottom of the screen in this video. So we are here to help you. Once again, always remember, it's when you pass, not if you pass. Thank you for joining us again today, and hopefully we'll see you next week too. Talk to you soon.